In previous lecture, we wrote a little experiment that demonstrates the usage of orthographic camera. We implemented few methods. Actually, we implemented input polling, and we were manipulating the camera position and camera zoom levels. In this lecture, we will see what are different kinds of viewports and what is actually a viewport. So when we are dealing with different screens, it is necessary to have some strategy how those different screen sizes and aspect ratios should be handled. When we handle multiple screen sizes, that can be really painful, but you will see how easy it is to make the whole process of handling multiple screen sizes with LibGDX. With LibGDX, it is really easy to handle multiple screen sizes. So viewports, what are the viewports? Well, the viewports are built-in strategies to handle multiple resolutions. As we know, each phone has a different resolution, so the viewport is really helpful to handle those multiple resolutions. The easiest explanation of viewport would be that viewport controls the strategy for scaling the world to the screen. We have seen that whenever resize event occurs, we need to tell our viewport and we need to inform our viewport about this resize event, and viewport needs to be updated. When viewport gets updated, that will automatically recalculate the viewport parameters, and it will also update the camera. So viewport manages the camera, and as we have seen, when we set the third parameter of update method to true, it manages the camera to center the camera. We have seen these world width and world height. So what are these world units? Many people make a mistake of thinking in pixels when they create their games, and that is something that we really need to avoid. We should never think in pixels. We need to think in world units. If we think in pixels, then there will be a lot of unnecessary multiplying and dividing by constants. For example, we will have weird pixel per unit, or some people call it pixel per meter ratios, and we will have all these multiplying and dividing all around our code, which will make our code harder to understand. And there are many other problems that will arise if we continue thinking in pixels. To avoid those problems that can arise, we should always think in world units. So what is a world unit? If we take a look at our desktop launcher, in GDX sampler launcher, we configured our canvas width, which is the width of our part of our application where the LibGDX application is, and our canvas width is width minus cell width. So our canvas width is 1080 by 720 pixels. So if we go back to our orthographic camera sample, we have seen that there is 10.8 and 7.2. And if we have pixels 1080 and then we divide them by 100, we will get result 10.8. So it means that this 100 is our pixel per unit. So one world unit is 100 pixels. And here we would have 720 divided by 100, which is 7.2. So our world will be made of units that are 100 by 100. So in this case, we would have a width of 10.8 units and 7.2 units. So this is to handle different aspect ratios. Before, like before 2.5 or maybe 3 years ago, LibGDX didn't had viewports, and back then we had to manipulate our camera and invent different strategies to handle multiple screen sizes. So if you ever download some game that is pretty old and the code is pretty old, you will see something in resize like camera.viewport width is width divided by some number, let's say 32, and camera.viewport height is camera.viewport width multiplied by height divided by width, and then camera.update. So we don't need to invent any dividing and multiplying strategy for different screen sizes. We can just use viewport and everything will be handled automatically. So there are different viewports in LibGDX, and we will go one by one and explain each of them. So about different aspect ratios, there could be like 4:3 aspect ratios or 16:9 or 16:10, and viewport can handle everything for us. So let's prepare a little experiment with viewports. We will create a new class and we will call it viewport sample. In this sample, we are going to extend our sample base. Again, just create a logger, which is pretty fast with our live template. Then we need public static final sample info as new sample info with viewport sample class. Our create method, where we will enable our debug logging to application log debug, and we need to go to our sample infos with Ctrl N. We can just type sample I and go to our class, add our viewport to our list. So viewport sample.sample info, and with Alt Tab we just go back to our class, which makes it pretty fast, so we don't need to waste time on searching everything on the packages. Okay, so again we will need those three little classes, which is private orthographic camera, and then private viewport, and we will call it current viewport, not the viewport. So current viewport. Then we need batch, sprite batch. We will need a texture, and we will need bitmap font. And let's import this texture. In create, we need to instantiate all our variables, but before that we will create two constants for world width and world height. So this time we will use a bit bigger values, so float world width will be 800 world units, and world height will be 600 world units. And we also need a little array map with key string and value viewport, and we will call it viewports, and just instantiate it as a new array map. Array map is just a collection with key value pairs, so we can by the name of the viewport we can find our viewport inside the map. Okay, so let's create our camera is new orthographic camera. Then batch will be new sprite batch, so new sprite batch. Texture will be new texture with GDX GDX.files internal, and row level dash bg dash small dot png, and our font will be new bitmap font gdx.files.internal, and inside the folder fonts there is osbold-32.fnt. Okay, then we will create a few other methods, which are create viewports, and select next viewport. Then before we continue, we need our resize method and we need our dispose method. So inside the resize, we will just call our current viewport and resize, okay, viewport update, and screen width and screen height, and the third parameter we will put true, so width, height, and then true to center our camera. So we don't need to do any dividing or any calculation for centering the camera. And in dispose, we need to dispose our resources, which are batch dispose. Then we have a texture, which needs to be disposed, and font also needs to be disposed. Okay, so now we will just put a little input processor, and since our sample base is input processor, it implements input processor, we can just override our little method, and that method will be touch down. So touch down, and here we will return true, and here we will also call select next viewport. So let's create our viewports. We will create a method private void create viewports, and here we will populate our object map. So array map viewports dot put, and the key will be stretch viewport, or simpler would be just to call stretch viewport dot class dot get simple name, and for the value we will use new stretch viewport with world width and world height. And here we will also need to put our camera, so the viewport knows which camera are we using. Okay, camera, and then next viewport will be our fit viewport. So fit viewport class get simple name, and then new fit viewport with world width, world height, and camera. The next viewport is fill viewport, so fill viewport class get simple name, and new fill viewport with our world width, world height, and our camera. And we have another viewport, which is screen viewport, so screen viewport class get simple name to get the name of our viewport, and new screen viewport, and it just needs a camera, so it doesn't support, the screen viewport doesn't support these virtual units. It will always be the same size as the screen, as we will see that later. And now again in our viewports map we will put our next viewport is extend viewport. Let's get the name, and new extend viewport with world width, world height, and our camera. And we need we need to set our current viewport index to be -1. Let's just declare our current viewport index, and we also need to declare the viewport name. So private int current viewport index and private string current viewport name. Now we need to implement our select viewport method. So we can just write private void select next viewport. And here we will just select our next viewport. The easiest to do it is to make our current viewport index equals current viewport index plus 1, and then we use modulus operator with viewports.size. For those who have never seen modulus operator, it is just the remaining of dividing. So for example, if we divide, let's say 5 by 2 with modulus operator, that will be 1. And the reason for that is because 2 by 2 is 4 and the remaining is 1. Reminder. Actually, it's called reminder. And now let's make our current viewport. Should be viewports get value at current viewport index. So since we changed our current viewport index, we want to make our current viewport to be the viewport at that index. Then we need manually we need to call update here, and we will pass GDX graphics get width and GDX graphics get height. And now we want to set our current viewport name. Should be viewports get key at current viewport index. And let's debug to console. Selected viewport is current viewport name. So in the next lecture we will continue with our drawing. But before we go to the next lecture, I will just explain once more what is going on in this create viewports. So we are populating our map with all the viewports that are in LibGDX, and we are resetting our current viewport index.